Hi, in this lesson, we are going to discuss about the Unix processes. Let us try to understand what is a process. A process can be defined as an instance of a program that is currently under execution. In Unix environment, there could be n number of processes which could be running in the foreground as well as in the background. These processes would have a certain attributes such as process ID, process name, and the terminal ID, which is mainly used for identifying those processes. These processes may also consume the system resources such as the CPU and memory. The, the allocation of resources to the processes is done by the kernel. So the kernel plays a very important role in the process management. Kernel is also responsible for determining the process priorities and assigning the resources as and when required. Let us try to understand the different types of processes. The first type of process is called as the user process. Most of the processes that is run in the Linux environment are the user processes. The user processes are the processes that are initiated by the users and runs in the user space. User processes are those processes which could be executed by the user, such as running a database application or opening a Firefox, etc. The next type of process is called as the daemon process. The daemon processes are designed to run in the background. Generally, they are known as the background processes. The daemon processes are responsible for listening for any kind of incoming requests. The HTTPD daemon processes would listen to the request for viewing the web pages. Similarly, the cron processes would be responsible for execution of cron jobs at the preset interval of time. The behavior of the daemon processes can be modified by changing the configuration scripts or changing the state of the services. The daemon processes are directly associated with a certain service. The daemon processes are the processes that run in the background that manage the operating system services. The next type of process is called as the kernel process. The kernel process execute in the kernel space. They are considered to be more powerful than the daemon processes. The behavior of the daemon processes can be changed by modifying the configuration files or changing the state of the services, whereas the kernel processes cannot be changed in the similar manner. However, changing the behavior of the kernel processes may require recompiling the kernel itself. Now let us try to understand some of the process-oriented commands in Linux. The first command we are going to discuss is the ps command. PS stands for process state. So this command gives you the list of all the processes running on the terminal. As we discussed earlier, every process has got a list of attributes associated with it. Some of the attributes are the process ID, the terminal ID, the time for the execution, and the name of the process or the name of the command. Every process in the Linux operating system is associated with a process ID. So the process ID is mainly used for identifying each and every process. Each of these processes would execute on the respective terminals. So this represents the terminal ID or the ID of the terminal where this process is being executed. This indicates the time taken for the execution. To list all the processes running in the Linux operating system, we can use the command ps-capital A. This gives you the list of all the processes that are running in the Linux operating system. When we say all the processes, it includes the user processes, the daemon processes, and the kernel processes. As you can see from this output, the systemd is the very first process. In Linux operating system, the systemd process is considered as the system initialization process. This process is responsible for initializing all other processes and services in the operating system. Another command that lists all the running processes in Linux is ps-en. This command gives you the detailed description about each and every processes. For example, the user ID, the process ID, the parent process ID, the priority for the processes, the nice value, the terminal ID, time, and the command. To list all the processes with respect to a particular user, we can use the command ps-u followed by the name of the user. This command lists all those processes associated with the root user. To list all the processes running on a particular terminal, we can use the command ps-t followed by the terminal ID. To list the hierarchy of all the processes, we have a command called pstree. This command gives us an idea about the order in which each and every processes are initiated. As we discussed earlier, the systemd is considered to be the system initialization process. Hence, it acts as the parent process for almost all the processes in the Linux operating system. To list all the processes along with their process ID in the process tree command, we can use the pstree command with -p option. As it displays the hierarchy, it also prints the process ID associated with each and every processes. Suppose if we want to display the details with respect to a particular background process, we can use the command ps followed by -c followed by the name of the process. In this case, it displays the details of only the firewall daemon process. Similarly, we can print the details of the SSHD process. Now let us discuss about process management. There could be some scenarios where some processes may not be responding or they could be in the hung state. In such cases, the administrator would stop such processes. In Linux environment, we can use the kill command to stop the running processes. For example, Now in this case, kill is the command which is used to kill the process. -9 is the option for kill signal, and 13456 is the process ID associated with respect to the process. So in this example, 13456 is the process ID associated with respect to bash. So let us see what will happen if we execute this command. As you have noticed, it has closed the terminal. The reason being, the program which was running inside the terminal was the bash. So once when we kill that process, the terminal got closed. Similarly, there could be different options that could be used with kill. To display the list of all the options, we can use the command kill-l. This gives you the list of various options that could be used along with the kill command. As an example, we can use the option number 19 to stop a running process. To continue the stopped process, we can use the option 19. To terminate a process, we can use the option 15. To interrupt a process, we could use 2. Now let us discuss about nice values. Nice values are the user space values that can be used to control the priority of the processes. A user can change the priority of the user processes. The nice values can range from -20 to +19, where -20 is considered to be the highest priority and +19 is considered to be the lowest. 0 is considered to be the normal nice value. So it is through the nice value which is used to control the priority of the processes. Now let us try to understand nice value in detail. As you can see here in this scale, the normal nice value is considered to be 0. The scale towards the right side are positive and the scale towards left are negative. Smaller the values, higher the priority. Higher the values, lower is the priority, which in turn controls the value for the priority, where normal priority value is considered to be 80, low priority is considered to be 99, and high priority is considered to be 60. So as the nice value increases, the priority decreases. And as the nice value decreases, the priority increases. So let us try to understand this in practical. Now let us run one process with a specific nice value. To set the nice value for a process, we have a command nice. To set the nice value for the processes, we have the command nice followed by option n, followed by the nice value, followed by the process. In this case, we are sending a process to the background for the execution. When you suffix a process with ampersand, that process will be sent to the background, and it returns the process ID associated with respect to that process. So let us try to understand the nice value and the priority value associated with this process. As you can see here, the nice value has been set to 10, which has set the priority value to be 90. Now in this case, the priority of the process is very low. In order to increase the priority of this same process, we can use renice followed by the nice value followed by the process ID. Now, as you can see here, the nice value is negative, which has reduced the priority value, which means that this process now currently has the highest priority. Because as we discussed, lower the priority value, higher is the priority. Higher the priority value, lowest is the priority. Let us discuss some of the concepts of services on Linux operating system. There could be some services in the Linux operating system. Each of these services would have a specific functionality, and all those services are managed by a daemon process. As we had discussed earlier, the daemon processes are responsible for managing some sort of services in the operating system, as they would be listening for a certain event as what operation needs to be performed. For example, the HTTPD daemon processes would be listening for incoming request to view the web pages. Similarly, the cron daemon process is responsible for managing the cron jobs and executing them according to a preset time values. So likewise, there could be some services and their associated daemons running in the Linux operating system. In Linux environment, the systemd is considered to be one of the most important service manager. The details of all the service are stored in their respective files, which are known as unit files under the location /user/lib/systemd. We can manage and interact with the services by using the systemctl command. Now let us see how to interact with the services. In Linux environment, we can control and interact with the services by using the systemctl command. Using systemctl command, we can check the status of a specific service through their daemon process. For example, in this case, as we check the status of the SSHD daemon, it shows that this particular service is currently active and it is in running state. To stop the service, we can use the command stop. Once again, when we check the status of the service, it shows that it is currently inactive. Sometimes we may have to stop the services in order to conserve the system resources. So if there are any unnecessary services running in the background, then the administrator would decide to stop those services. In order to start the same service, we can use the command systemctl followed by start followed by the name of the service. Once again, if you check the status of the service, you can see that it is in the running state. Services can also be configured to start during the boot time. For example, now in this case, as you can see here, this service is enabled to start during the boot time. In case if you want to disable this service so that it is not started in the boot time, we can use the command systemctl disable SSHD. Now if you check the status of SSHD, you can see here this particular service has been disabled to start during the boot time. You can also notice that the vendor preset value has been set to enabled. The vendor preset value is the value that is set by the default, or otherwise the default value which is set by the vendor. So some services would have the value disabled and some would have enabled. As we know that the SSHD daemon process would be listening to its port number for any kind of incoming connections from a remote server. So when this particular service is disabled, then the systems which are remotely connected in the network would not be able to connect to this particular server. So you cannot connect to this particular server using the SSH method. To bring back this service in the enabled state, we can use the command systemctl enable and if you check the status, you can see here this service is enabled to start during the boot time. Now this allows users from the other systems to connect remotely to this particular server using SSH. So in this lesson, we have learned some of the process-related command in Linux, and also we have seen how to manage the services in the Linux and Unix environment. Thank you.